Audio Jungle.
Hey guys, welcome to 1.4 Big Idea 8. We're going to talk about whether or not a number is prime or composite. Now obviously you need to know what a prime number is and what a composite number is, and I'm going to get to that, don't worry. But for now I kind of want to go through an exercise with you to give you a little bit of a demonstration of what I'm talking about. So I just started listing numbers. I wasn't doing anything besides counting. Guys, I started at 2, listed out all these numbers here. And what I'm going to do is I'm going to cross out all the numbers that are multiples of another number. Here's what I mean. I'm going to start with the number 2. 2, I am not going to cross off, but I am going to cross off all of his multiples. So the multiples of 2 are 4. You guys count by 2's for me. 2, 4, 6, 8, 10, 12, 14. You guys may remember the multiples of 2 are all the even numbers. So another way you can think of this is I'm crossing off all the even numbers. Some of my people even struggle with that, so that's okay. Every second number is a multiple of 2. So you can just go 1, 2, cross it off. 1, 2, 1, 2, 1, 2, 1, 2, and so on. Okay, got rid of all my 2's. I'm going to keep proceeding in this fashion, crossing off all the multiples. So next number is 3. The multiples of 3 are 6, 3, 6, 9, right, is the next one. And then I can do, again, that counting trick. 1, 2, 3, that's 12, 15, 18, whoops, 21, 24, 27, 30, 33, 36. Some of these numbers are getting crossed off twice, huh? That's okay. It's because they have more than one factor in them. Okay, so I did 2, I did 3, I'm going to do 5 now. So my 5 times tables, those are easy. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and I'm off my list already. Okay, got those. I'm running out of marker colors. I guess I'll do black. Next number, 7. Multiples of 7. 7, I told you guys to memorize these. Did you memorize them? 7, 14, 21, 28, 35, 42, 49. Okay, after 7's, what's the next? You guys notice what I'm doing here? I'm skipping all the ones that are crossed off. I don't care about those. Keep on going. There's my next uncrossed off number, that's 11. Okay, now I'm going to cross off all his multiples. So the next, you guys know your 11 times tables too, right? 11, 22, 33, 44. I'm already off my list. Okay? Next number that's not been crossed off is 13. I don't want that color. I want this color. That's the color I want, 13. Okay, you might not know your multiples of 13 because you might not be a ninja. I'm a ninja. That's okay. We can just add 13s to figure it out in a hurry. 13 plus 13 gives me 26. Add in another 13. I get 39. Multiplication is just repeated addition, guys. Add in another 13. That's a little more work. 52. Cool. Multiples of 13 were already all crossed off. So next number I have is 17. And I'm going to tell you right now, 17, 34. Oh shoot, I don't know the next one. Look at that. If I wasn't on camera, I could probably come up with it. That's what I say. So 51 is already off. You're going to see that most of these are already crossed off. Okay. So I'm going to stop right now because I'm going to tell you we've already crossed off all the multiples for the rest of these because we're looking at their 2 and 3 times facts, which we've already looked at our 2's and our 3's. So 17, what else isn't crossed off? 19 is left. 23 is left. 29 is left. 31, 37, 41, 43, 47, 53. Now, if I had a much longer list, I would keep going and crossing off all the multiples. But because I have this short list, I stop my numbers here. I've already gotten rid of all my multiples. Okay, so why did I bother to do this? Who cares? The whole point of this, the numbers that I've circled are the numbers that cannot be broken down any further. They don't have any other numbers inside of them. They are just themselves. Because we crossed off all the multiples, we crossed off everything that's composed or made of another number. And that leads us right into where we want to go. We've got two types of numbers. We've got the numbers we've circled. Those are called prime numbers. Prime numbers are what's left when you cross off all the multiples. But the math definition that they'll give you is they'll say prime numbers are numbers that have exactly two factors. One and itself. That sounds like a very funny definition. Let me show you what I mean. Let's pick one of these circled numbers here. I'm going to do a small one. How about 11? Okay? So I'm going to prove to you that 11 is indeed a prime number. I'm going to do a factor rainbow. We learned about that in the last video for 11 to see what all his factors are. Well, the first number in a factor rainbow is always 1. And the last number is always the number itself. Now, we'll ask ourselves, does 11 divide by 2? Answer is no, that's an odd number. Does it divide by 3? 3, 6, 9, 12, I've gone right past 11. Does it divide by 4? No, it doesn't. It didn't divide by 2. It's not going to take any even number. Well, how about 5? Obviously not 5. Same thing for 7. Same thing for 9. We've got nothing in here. So my only two factors are 1 and the number itself. That's what I'm talking about when I say this definition. So 11 has only two factors, and so 11 is prime. You guys see that? Does that make sense? So if all the circled numbers are prime, what are the crossed off numbers called? We have opposites here. The circled numbers are prime, but the crossed off numbers are called composites. Now, that's a long word, but what you're going to notice in the word composite is it kind of looks like the word compose. And to compose means to make or to build. So like if you compose a musical piece, then you've built a piece of music. And so a composite number is made or built of other numbers. It's got other factors inside of it. So what a composite number is it's a number it has more than two factors. It's a number with more than two factors. So let's prove it to ourselves that these crossed off numbers are indeed composite. I'm going to pick the number 15, and I'm going to look at all his factors. Again, I need to use a rainbow to look at factors. We always start with 1, end with 15. 15 doesn't divide by 2, but guys, it divides by 3. 3 times 5. You see that? We've got more than two factors. We have 4. Doesn't really matter. All we need is more, and we have it. And so we can say that this is what we call a composite number. It's composed of other numbers is the way I think of it. It's got other factors hiding in it. Okay, wonderful. That's the definition. Let's do some practice problems. So guys, I'm a firm believer in not having you memorize a ton of information. You know, I use tricks all the time so we don't have to memorize. But here's something I am going to ask you to memorize. And that's the first 5 primes. These are so important to me, in fact, that I actually recommend you all tattoo it right here on your forearm. I'm just teasing. But 2, 3, 5, 7, and 11 are the first 5 prime numbers. And we are going to find them so useful, I'm going to ask you to memorize them. Now, those aren't the only prime numbers, obviously. We looked at that whole big, long list. We had a lot of circled numbers. And in fact, mathematicians will tell you there's actually an infinite number of prime numbers, so they pretty much go on forever. But good news is, these are the only 5 I want you to memorize, okay? So you're going to memorize those for me, 2, 3, 5, 7, and 11. Say it a few times over. 2, 3, 5, 7, 11. Those are your lucky numbers. And we're going to use them to answer a question like this. Is 64 prime or composite? And so basically what it boils down to is if I can't find the first 5 primes, the likelihood is, unless it's a pretty large number, that this guy is a prime. I'm not going to find any factors if I can't find these 5 factors. So that's why I want you to memorize it. That's why they're super useful. I don't want to check for every number between 2 and 64. I bet you don't either. So all I'm going to look for are these 5 numbers. Now this one's real obvious. Right away this number's screaming at me because he's even. You guys see that? He's an even number. He clearly has a 2 in him. I've found an extra factor. Anytime you find an extra factor, our number is composite. Now I'm going to do a bunch of these problems. Y'all are going to feel like I'm talking forever, but I really want you to see the easy ones so we can rule the easy ones right out. So here's another real easy one. Is 85 prime or composite? Another dude who's just yelling composite at me. I just know he's a composite because I can see right by looking at him. And you should be able to by now too. He's got a 5. 85 ends in 5 or 0. And we know when something ends in 5 or 0 that it has a factor of 5. Well, I found an extra factor. This thing is a composite. I know what you're thinking, will she ever get to primes? I promise, I will. But here's another easy one. Is 77 prime or composite? Again, I chose a number that is obvious. This is a double repeating digit. Guys see that? 2 7s? We know that that is the divisibility trick for 11s. He's got an 11 in him, so he's obviously a composite. I found an extra factor. Okay, a lot of talk about composites. Let's look at some more problems. We're going to find some primes as well. So I showed you the easy problems, the ones that just scream to me that they're composite. However, here's where most students get messed up. Large, odd numbers throw people really, really bad when we've been asked to determine whether each number is prime or composite. So let's be really logical about how we deal with these numbers, okay guys? I told you all you need to check for is the first 5 primes. And I know you have them memorized now, so you can go ahead and tell me what they are. I feel like we're Dora now. 2, 3, 5, 7, and 11. Do you feel condescended to yet? Okay, so there's my first 5 primes. Those are the ones I gotta check for. And that's all I gotta do. If I can find one of these numbers in 51, I can declare that this is composite. If I can't find any of these 5 numbers, I can be fairly certain that this must be a prime number. And so that is how I'm going to do it. Now, you guys probably heard me say fairly. It's like she sounds like she doubts herself. Well, basically the idea is if I get some really large numbers, I might have to go beyond 2, 3, 5, 7, and 11. But you have to get pretty high, and we don't see that type of problem on this test, so don't worry about it, okay? So I'm going to see if 51 divides by 2. Real quick, easy to tell, it's an odd number, so 2 is not going to work out for us. Next thing I'm going to look at, I like the easy ones first. I'm going to rule out the easy ones first, so I'm going to look for 5s. Doesn't end in 5 or 0, and so no 5s. Also, 11s are easy to check for. It's not a repeating double digit. It would have to be 5, 5, or 1, 1. There's no 11 in there. Okay, so now I'm left with the 2 hard guys. Let's deal with 3 first. 3's not too bad. You guys remember your trick for 3's? I know you all remember it, right? Sum of digits. So I add my digits. 5 plus 1 is 6. So does 6 divide by 3? Sure does. So does this number. I found a factor. I found a factor. When you find a factor, we are composed of other numbers, so we are composite. I found an extra factor. I'm a composite. Okay, now let's check out 61. Same process. I'm looking for the first 5 primes. 2, 3, 5, 7, and 11. 7, 11, I like it. Okay. So 2, 3, 5, 7, and 11. Obviously, it's an odd number. I don't have a 2. Doesn't end in 0 or 5. I don't have a 5. And we don't have repeating digits, so no 11. So I'm back to the 2 little snots, 3 and 7. So I'll do my sum of digits for 3s. 6 plus 1 gives me 7. Now do not make the mistake that some of my students make and say, oh, that means it divides by 7. No. This is the trick to find 3s. This does not divide by 3, so neither does this number. I can cross off 3. Okay, so last thing to check is for 7s. How do I check for 7s? There's no trick for 7s. You've got to divide. Remember how I asked you to memorize your 7 times tables? I know mine. So I'm going to start with 7 times 7 is 49. 7 times 8 is 56. 7 times 9 is 63. Went right past this number, didn't hit it. Therefore, 7 does not go into 61. Hope you guys flowed with that. If you didn't, go back and memorize your 7s. Okay. So I found no factors here. 2, 3, 5, 7, 11 didn't work. This is a fairly small number. That's all I need to check for. I can be confident that this has no extra factors and is therefore prime. So 61 is a prime number. 51 is not. A lot of people just assume they're both prime. Okay, let's look at 91. Apparently I like numbers that end in 1. Okay, so again, checking for my first 5 primes. And I won't walk you through it again, but there's no 2, there's no 5, and there's no 11 there. So I'm left to check for 3s and 7s. Okay, so I'll do my trick for 3s. 9 plus 1 is 10. Does 10 divide by 3? Does not. And so neither does 91. Last thing to do is to divide by 7. This is a large number, so long division is actually handy. 7 goes into 9 once, with a remainder of 2, drop a 1, and you should be able to see by now, 7 goes into 21 perfectly, 3 times, with no remainder. See that? And so I found a 7. So once again, I would caution you, 3s and 7s hide. Okay? So, found a factor, we are composite. We're composed of other numbers. Got that? Okay. Last number I'm going to do, 167. This is about our high ends that we're going to be able to work with the first 5 primes. But I just wanted to give you a shot to try it with a larger number. Same process, not hard. Here we go. First 5 primes are 2, 3, 5, 7, and 11. Y'all are sick of me saying it already, but I'm going to say it till it's burned in your brain. 2, 3, 5, 7, 11. Does 167 divide by 2? It does not. It's odd. Does it divide by 5? A real quick final digit check will tell you no. Does it divide by 11? My double digit trick does not work on 3-digit numbers, guys, so I've got to check. 11 into 167. 11 goes into 16 once, with a remainder of 5. 11 does not go into 57 perfectly. I've got a remainder here, and so the answer to that is no. Okay? How did we check for 3s? Sum of digits trick. There we go. Apparently I really am on a Dora kick. Keep having you guys repeat after me. Okay, we'll do our sum of digits trick. 1 plus 6 plus 7, 7, 14. Okay, 14. Does 14 divide by 3? It does not, so neither does 167. Don't have a 3 in there. Last thing to check for is 7s. 7 goes into 16 twice, with a remainder of 2. 7 goes into 27, what's that, 3 times? Yep, with a remainder of 6. I don't know why I put that minus there. Okay, so remainder is 6. I have a remainder, it does not divide. I have ruled out all my factors, and so what does that mean? When you have no factors left, this guy must be a prime. Okay, that is how we do that. So here's your homework assignment for this lesson. Again, go to Quizlet. I stopped writing Quizlet. I got lazy, guys. You're going to go to set 1.40. That's a little o. And the set is entitled Prime or Composite. You can try some of these for yourself. Don't just guess. That's where you'll go wrong. Please use the trick where you try for your first 5 primes. What are your first 5 primes? I know you remember. 2, 3, 5, 7, and 11.